Have you ever stopped to think about how all the different parts of an app, maybe even parts built by totally different teams, manage to work together so perfectly? Well, it's all about communication. It's like a secret conversation happening millions of times a second inside your phone or computer. And in this explainer, we're going to pull back the curtain on exactly how code talks. You know, it really all starts with a problem that every single programmer can relate to: laziness. Okay, maybe a more professional way to put it is a deep, deep love for efficiency. I mean, why would you write the same 10 lines of code 100 times when you could just write it once? That's the big idea we're going to dig into. And here it is, the before and after. Just look at the left side. That is the programmer's nightmare. It's repetitive, it's messy, and if you find a bug, you have to fix it in every single one of those places. But then look at the right. So much better. That's the elegant solution. One single reusable block of code. You write it once, and then you just call on it whenever you need it. This simple idea is what makes all modern software even possible.
Now, this reusable block of code, it has an official name. We call it a subprogram. You can think of it like a specialized mini-program. You might know them as functions or procedures that's designed to do one specific job really, really well. It's a perfect example of something called process abstraction, which is just a fancy way of saying we can use this little tool without having to worry about all the complicated details of how it actually works inside.
What makes these subprograms so incredibly powerful is that they're predictable. They're not just random pieces of code floating around. They follow very strict rules. There's only one way in. The main program that called it literally just pauses and waits for it to finish its job, and when it's done, control goes right back to the exact spot where it left off. That reliability, that predictability, that's the foundation that lets developers build massive, complex applications. Okay, so we've solved the repetition problem. We've got these neat, tidy, self-contained subprograms. Awesome. But this creates a brand new and, honestly, a much more interesting challenge. If each subprogram is its own little world, how does the main program get at the information it needs to do its job? How do they actually talk to each other?
And the answer is something called parameter passing. You can think of parameters as the official messages or the data packets that get sent from the main program over to the subprogram. This is the communication channel, the pipeline that lets them work together. But as it turns out, there are a couple of very different ways to send these messages.
And this is where things get really fascinating, because there are two fundamentally different ways to do this. The first method is called pass by value, which is basically like saying, hey, here's a copy of my data. The second is pass by reference, which is totally different. It's like saying, here's the location of my original data. And that distinction, well, it changes everything.
Let's start with pass by value. The best analogy is a photocopy. Imagine you have a super important document. You make a copy and give it to a colleague. Now they can write all over that copy, spill coffee on it, draw on it. It doesn't matter one bit because your original document is safe and sound in the file cabinet. This method is all about safety. But if that document is 1,000 pages long, making all those copies can take a lot of time and use up a lot of paper.
Now, pass by reference, this is a whole different ballgame. This is like giving someone the address to your house and the key to your file cabinet. They go directly to the original document. It's incredibly fast and efficient. No time or resources wasted on copying. But, and this is a big but, there's a risk. Any change they make to that document is permanent. They are editing the one and only original.
So, let's look at how this plays out in some actual code. Here, a program wants to swap two values, A and B. But instead of sending the numbers 10 and 5 to the swap function, it sends the memory location, the actual address where A and B are stored. The subprogram then uses those addresses to go directly to the source and swap the original values. So when it's done, as you can see in that last step, the main program sees the change. It's permanent.
And this brings us right to the heart of the matter, the ultimate question for any software developer. What do you choose? Do you go with the safety of making a copy? Or do you go with the speed and efficiency of sharing an address? Like with most big engineering questions, there's no single right answer. It's all about trade-off.
So let's just boil it all down. It's simple, really. Pass by value gives you safety. Your original data is always protected, period. Pass by reference gives you efficiency. You avoid that performance hit of making copies, which is absolutely critical when you're working with massive amounts of data. The choice a developer makes really just depends on what they're trying to accomplish in that specific moment.
And please, don't underestimate how huge this decision is. This isn't just some abstract concept from a textbook. This one choice, copy or address, has a direct and profound impact on how fast your apps run, how much memory they use, and how likely they are to have really weird, hard-to-find bugs. It is a genuine cornerstone of good software design.
So here's a thought for you. The next time you're using an app, and it feels incredibly fast, super responsive, or maybe it's just remarkably stable and never crashes, take a second to think about those millions of invisible conversations happening under the hood. Is that snappy performance built on the raw efficiency of passing addresses, or is its rock-solid stability built on the safety of passing copies? Chances are it's a very, very clever mix of both.